go ahead.
I really don't know how to do this, so I found the formula. It's hypotenuse equals leg times the radical 2, and so I just plug in 6, that's hypotenuse, divided by 6, I got y equals 6 to the radical 2.
Thank you. Gabby, tell us, do you agree or disagree? Okay. Now, question, you said hypotenuse equals leg times the square root of 2, and you plugged in 6 for the hypotenuse and the square root of 2, and then y for the leg. Does everyone agree with that? Okay. Now, when you're solving an equation, you're trying to get the variable by itself. So, what is over there on the same side of the variable? Okay, so what happens to the 2 square roots of 2 on the right side?
These cancel out.
Okay, so now you have 6 over the square root of 2 equals y. So I would write that out. 6 over the square root of 2 equals y. What is wrong with that fraction?
The radical can't be on the bottom.
A radical cannot be on the bottom. How do you get a radical off the bottom?
You times both by the radical.
Yeah, you times both the top and the bottom by the square root of 2. So times the 6 by the square root of 2 and the square root of 2 by the square root of 2. All right, now when you multiply fractions, you just multiply straight across. What's the square root of 2 times 6?
6
Yeah, 6 square roots of 2. So that's your numerator, 6 square roots of 2. What's square root of 2 times square root of 2? 2. So it's 6 square roots of 2 over 2. Now the thing you want to check for is, can you reduce that?
Yeah.
What is 6 over 2 reduced to?
3.
Perfect. So it'd be 3 square roots of 2 would be your final answer. Perfect. Now, hopefully, after doing this clean, hopefully you've realized that there's a pattern. If they give you the leg, if they give you a leg of a 45, 45, 90 triangle, all you have to do is multiply it by the square root of 2, and that gives you your hypotenuse. So, for instance, let's say that they gave you a leg is 7. Well, this other leg is automatically 7, and the hypotenuse is going to be 7 square root of 2. Okay. Let's say they gave you this leg here, which is 12. Well, this leg here is going to be 12. This leg here is going to be 12 square roots of 2. Okay. Let's say they gave you a leg to be 1. Well, this leg is automatically going to be 1, and this is going to be 1 times the square root of 2, which is just the square root of 2. Okay. Every time. If they give you the hypotenuse, then you're going to divide by the square root of 2 to get your legs. So let's say that this is 5. You would do, your leg would be 5 divided by the square root of 2. Now, hopefully you've realized that the pattern, anytime you're dividing by a radical, your answer, let's say it's x over the square root of 2, it's automatically going to be x square roots of 2 over 2. X over the square root of 3 is going to be x square roots of 3 over 3. So 5 over the square root of 2 is going to be 5 square roots of 2 over 2, automatically. So hopefully you can do that just by looking at it. So this side would be 5 square roots of 2 over 2. This side would be 5 square roots of 2 over 2. Let's say they give you the hypotenuse is 25. 25 square roots of 2 over 2. 25 square roots of 2 over 2. The only thing you want to check out for is if the hypotenuse is even. Let's say, for instance, it's 24, because that would be 24 square roots of 2 over 2, and 24 divided by 2 is 12, so it'd be 12 square roots of 2 for the legs. So notice how quickly I'm able to solve that without actually going through and doing all of this work here. That's what your plan should be also. That's what your goal should be, to be to automatically be able to simplify it very quickly. All right, what questions do you have for me on the bell ringer? Okay. Today we're going to start section 10.3, trigonometric ratios. And then tonight you're going to have a homework assignment. It's a worksheet over this, okay, over 10.2. Tuesday and Wednesday you'll have a worksheet. And yes, you will need to bring your stuff tomorrow. The award ceremony usually goes into a little bit of third hour, but then we're always in here for like the last half. You'll get your assignment when we get in here. You'll turn in your homework assignment. We'll do the bell ringer. You'll get your worksheet, and then you'll have the rest of the class to work on your worksheet. Whatever is not finished, you'll have to take home and finish for homework. I've already made the worksheet. It's 5 problems. Wednesday, you'll do an assignment on big ideas. Thursday, we'll review, and Friday is your chapter 10 test. And then next week, we're just going to review for the final. And I think our final's on Wednesday. Trigonometric ratios. It says, our goal for today, students will be able to use the sine, cosine, and tangent ratios. This is probably my favorite thing in geometry. It is like the easiest thing in trig. So you can actually say that you are doing some trig today.
Trigonometry.
So if you plan on taking this class next year, this will be one of the first things you talk about. Alright, so first thing, this is something you need to have memorized to help you, and it's SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, now right now that seems very confusing. However, after we do it, it'll make it a lot easier. So first thing, see this triangle on your paper? First thing I need you to do is label the hypotenuse. The hypotenuse is always the hypotenuse. It's never going to change depending on which angle you look at. So just label that as your hypotenuse. It's always going to be the hypotenuse. However, your opposite and adjacent side is going to be different depending on which angle you're looking at. So mark angle A. We're looking at angle A. So mark that angle. The side opposite angle A, we've already know that is side BC. So mark side BC, put opposite, but make sure you say it's opposite of angle A. Opposite of angle A. And the side adjacent is the side next to the angle, so this one is adjacent to angle A. So make sure you put adjacent to angle A. Because if we were to be looking at angle B instead, the side opposite of angle B would be this same side that's adjacent to A. It would be opposite to B. And this side would be adjacent to B. So depending on which angle you're looking at, your opposite and your adjacent are going to change. Okay? So make sure that you are careful whenever labeling which side's adjacent and which side is opposite. It depends on which angle you're looking at. All right, and then let's write down the formulas. To find sine, it's opposite over hypotenuse, and I'm abbreviating. Opposite over hypotenuse. Notice sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. If you always find them in the order sine, cosine, tangent, then it's always going to be opposite over hypotenuse, adjacent over hypotenuse, and then the last one is going to be these top two numbers, opposite over adjacent, as long as you find them in that order. Okay. All right, does anyone need extra time to write the formulas down before I go on to an example?
Yeah.
Okay, let's make sure we're staying on task. All right, teacher model. It says find the sine of S, the cosine of S, and the tangent of S. That means angle S. Write your answer as a fraction and as a decimal rounded to 4 places. When you write it as a fraction, make sure it's in simplest form. Okay? So first, we're going to find sine. Well, actually, first, I'm going to write out SOHCAHTOA.
I did not write that.
Okay, so SOHCAHTOA, write that out so that way you have it. Sine of S is opposite over hypotenuse. Sine of S is opposite over hypotenuse. So look at angle S. The side opposite of angle S is the 63. So I'm going to label this side as opposite. And the hypotenuse is always across from the 90-degree angle, so 65 is the hypotenuse. Okay, so that would be 63 over 65, and I'm almost 90% positive that that does not reduce. It does not. So 63 over 65 is the fraction answer. And then for the decimal, I just changed it to a decimal, and it's approximately 0.9692. And there you go. Okay. Now we need to find cosine of S, of angle S. Well, cosine of angle S is adjacent over hypotenuse. Adjacent over hypotenuse. Okay. Well, if you look at angle S, the side adjacent is 16. And the hypotenuse is still 65. So it's 16 over 65. I'm pretty sure they do not reduce. And it does not. And rounded to 4 decimal places is 0.2462. Now I need to find tangent of angle S. Tangent is opposite over adjacent. Well, looking over here, if I look at S, the opposite is 63, and the adjacent is 16. And let's make sure it does not reduce. It does not. And this one, it stops at 4 decimal places, which means that I don't have to round. So this would actually be equals 3.9375. I did not have to round, so I would put equals. So it's 3.9375. And that's how you find the sine, cosine, and tangent of an angle. Notice it says sine of S, cosine of S, tangent of S. You have to put which angle you're doing it to, because if I don't, then they won't know which angle I'm talking about. So if I was doing it for angle R, I would put sine of R or cosine of R. Okay. All right. What questions do you have for me? Okay. Let's do one together. First thing you need to do is write down these numbers: 24, 25, and 7. Then I would write down the SOHCAHTOA. Okay. And it says angle D. So we're looking at angle D. Okay. So my first question is, which side would be the hypotenuse? Rayleigh. DF. Okay, perfect, because it's across from the 90-degree angle. Colton, which side would be opposite of angle D? That's an angle. What side? EF, perfect. So this side's opposite. And Kyle, which side would be adjacent to angle D?
DE. So how is that opposite?
It's across from it. It's the side that doesn't make the angle. So here's angle D. The two sides that make it are DE and DF. So it's the side that don't have the D. Okay? Now, write your formula for the sine of D. Ivy, what's the formula for sine of D? Opposite over hypotenuse. Always go back to this. O over H. S equals O over H. So opposite over hypotenuse. And Gabby, what would that look like as a fraction? And Gabby, can I reduce that? Okay. Did you say no?
Yes.
Okay, perfect. And then, Gabby, what is that as a decimal?
3.56.
Do 7 divided by 25. I think you did 25 divided by 7. Yep, 0.28. Notice I put equals 0.28 because I did not have to round. It's exact. Perfect. All right, let's do cosine of D. Braxton, what's the formula for cosine of D?
Adjacent over hypotenuse.
And Braxton, what side is adjacent?
24.
And what side's the hypotenuse?
25.
And can I reduce that?
Yeah, you get equals to 0.96.
Well, can I reduce the fraction? Not change it to a decimal yet. Can I reduce the fraction? No, there's no number. It goes into that 5 and 25 are the only, and 1 are the only factors. Now, what is 24 divided by 25?
0.96.
You said 0.96?
Yeah.
Yeah, and we didn't have to round, so I'm going to put equals. So equals 0.96. All right, and now let's do tangent of D. Andrew, what's the formula for tangent of D?
Over adjacent.
Opposite over adjacent. What side is opposite of D?
7.
And what side is adjacent?
24.
So 7 over 24. Can I reduce 7 over 24? And what is that as a fraction or as a decimal to 4 decimal places?
0.2916.
What number is behind that 6?
76.
So what does that 6 need to round to? 7. So 0.2917. And that's it.
That's all you gotta do.
All you got to do. All right, it says find the sine, cosine, and tangent of a 45-degree angle. Notice you don't have a triangle here. So what's the very first thing you think I'm going to do? Draw a 45-degree triangle. Now, all of these triangles are right triangles. So you have a right angle, and you have an angle that's 45 degrees. What's this other angle up here going to be? 45. Now, if this side over here were to be 1, what's this side over here going to be? What's my hypotenuse going to be? Square root of 2. Always. A 45, 45, 90 would be 1, 1, square root of 2. Okay? Because it's this side, the leg times the square root of 2, 1 times square root of 2 is square root of 2. Now, if it says find the cosine, sine, and tangent of a 45-degree angle, does it matter which of these two angles I look at? No, you can look at either one. I like to look at the bottom one. All right, so let me just label this A, B, and C just so it's easier for you to tell me which side is opposite, adjacent, and the hypotenuse, which we automatically know this side to be the hypotenuse, the square root of 2. John, which side is opposite of angle C? A, B, perfect. So this side's opposite. And John, which side's adjacent? Okay, so side BC would be adjacent. All right, so first let's do the sine of 45 degrees. Okay, so make sure you put sine of 45. What is the formula for sine again, Aiden?
Opposite over hypotenuse.
Opposite over hypotenuse. Let me write that up here again. SOHCAHTOA. Alright, so opposite over hypotenuse. Alright, Aiden, so what would I write?
1 over the square root of 2.
Now, is that fraction in simplest form? What would I do to get it in simplest form? And 1 times the square root of 2 is the square root of 2, and the square root of 2 times the square root of 2 is 2. So it's the square root of 2 over 2. Now this says nothing about writing it as a decimal, but let's type it in our calculator. Hit second square root of 2 divided by 2 and change it to a decimal. I got 0.7071. Did y'all get the same thing?
Yeah.
Now, what I want you to do next, y'all see that button on your calculator that says sign, S-I-N? Press that, and then type in 45, and then press enter.
0.8509.
You do sign 45?
Yeah. I got this.
I got the answer. I got the 72. 805.
Not that close.
I'm not sure that's sense.
Square root of 2 over 2. If you change it to a decimal, you should get the 0.7071.
I got 85 over.
Yes, some people. Oh, it's because you're in radians and not degrees. Go to mode and see where it says normal, then float, then radian. Change radian to degree. Then hit second quit. Now type in sine of 45. You should get 0.707106.
So you want us to degrees?
Yes, we only do degrees. We don't do radians.
So I don't even have to write the formula out. I can just do that.
That's
Right.
0.707.
Yeah.
Yeah, as long as you're in degrees, and that's what 40 is. 45 degrees. You won't deal with radians unless you take like pre-cal or calculus.
So I don't have to really write anything.
If you just do 1 over the square root of 2, then if you have one of these calculators, it'll give you the square root of 2 over 2. If you have one of those, it'll give you the decimal. And this one does not ask for the decimal, it wants this. So,
But like on the other ones, like
oh yeah, because you got to write it as a fraction first. This is a way to check your answer to make sure you did it correctly. All right, so now cosine of 45. Ben, what's the formula for cosine again?
This is
Adjacent over hypotenuse. All right, Ben, what's the adjacent side? What number is that? What's the number for the adjacent side? So if you look at adjacent, what number do I plug in? 1. And what number do I plug in for hypotenuse?
Square root of 3.
Now, this is not in simplest form because I have a radical on the bottom. What's 1 over the square root of 2 going to be once I get done simplifying it?
0.70.
Do what?
Do you think that would be the same?
Yeah, you got 1 over the square root of 2, and it simplifies to the square root of 2 over 2. And that's your answer. That's because your opposite and your adjacent side are the same number. So your answer is going to come out to be the same. All right, now let's do tangent of 45. Hayden, what's the formula for tangent of 45 again?
It is
I'm sorry, for the tangent one.
opposite and adjacent.
Opposite over adjacent. All right, Braxton, what is my opposite side?
your opposite side's 1 and then your adjacent's 1.
What does that reduce to?
1.
And there you go. Again, type in your calculator tangent of 45, and you should get 1. That's a way that you can check your answer.
Wait, there's numbers before.
Yes, there's a sine, a cosine, and a tangent.
It puts just G.
Oh, that's probably because you have alpha selected. Make sure you hit clear. Don't select alpha.
Alright, next, oh, sorry.
I went back to normal.
Because you put water, you want a big.
All right, let's do another one together.
No, look.
Find the sine, cosine, and tangent of a 30-degree angle. All right, so we have to draw a right triangle. Here's my right angle. This smaller angle's 30 degrees. What's this bigger angle going to be?
60.
60 degrees. Hey, we've also had a 30, 60, 90 triangle before. And if you recall, remember that cheat thing I showed you when we first started doing it? The side opposite the 30 degree is the smallest, so it's automatically 1. Your hypotenuse is 2, and your long side is 3, but it's actually the square root of 3. So it's 1, 2, 3, long side, but it's the square root of 3. Okay. Short side is 1. Hypotenuse, you multiply it by 2. Long leg, you multiply it by the square root of 3. All right, so it's talking about the 30-degree angle. All right, so Rayleigh, which side is opposite the 30-degree angle? Okay, so this one here, that's a 1. Perfect, so that one's opposite. And Rayleigh, which one's my hypotenuse? 2. And which one's adjacent? Perfect. All right, let me go ahead and write SOHCAHTOA.
What? I'm gonna end up spelling it wrong on the test. Put it up there and doing like 7 different.
All right, Colton, for sine of 30, make sure you put sine of 30. What's the formula for sine again? Opposite over hypotenuse. All right, so what would that look like if I plugged in the numbers, Colton? 1 over 2. Kyle, can I reduce this?
No.
Nope, that's my answer. And it doesn't say anything about putting it as a decimal, so I would just leave it as 1 over 2. All right, now let's do cosine of 30. Ivy, what's the formula for cosine of 30? And what numbers would I plug in for adjacent and hypotenuse? Okay, and is there anything I need to do to that to simplify it?
No.
No, the square root's already on top, so I'm good. As long as it's not on the bottom, I'm okay. Now let's do tangent of 30. Gabby, what's the formula for tangent again? And what numbers would I plug in? Now, is that simplified?
Yeah.
Can anyone tell me what they think the answer is going to be without doing any work?
1 radical 3 over 3.
Do I have to actually put the 1 in front?
No.
Perfect. So to get that, all he did was multiply the top and the bottom by the square root of 3.
Are you gonna take it off?
I would not, but if it's on big ideas would count it wrong, yes. Because you never put a coefficient for 1. We've never done that in math. Like if you see x, we automatically know there's a coefficient of 1. We don't put 1x, we just put x.
Yeah, I used to do that whenever I was done.
What, Miss Dicker?
No,
Or this year?
All right, before you do one with your partner, what questions do you have for me?
This is simple. Maybe not for Ben, but
Okay, so first thing I need you to do before you do your work with your partner is fill in the missing numbers, 24, 25, and 7. And notice this time it's find the sine, cosine, and tangent of angle F. Okay, so your opposite and adjacent side are going to change depending on looking at angle F. All right, so you get to pick your partner, only 2 people per table. So, and you have to be at a table, you get to pick your partner, only 2 people per thing. So go ahead and pick your partner and move over to your partner and work it out together. Gabby, what did you and your partner get for sine of angle F?
0.9.
What was your fraction?
24 over 25.
And that was 0.96. Okay, perfect. All right, you should not be talking. What about for cosine of F? Rayleigh, what did you and your partner get for cosine of F?
7 over 25 and 0.28.
Perfect. And Kyle, what did you and your partner get for tangent of F?
24 over 7.
And what is that as a decimal rounded to 4 decimal places?
3.4286.
Perfect. All right, what questions do you have for us before we move on to the next one?
Let's go to the next one. Let's do this.
Okay.
Cat.
All right, so first thing you need to do is write down the missing numbers, 65, 63, and 16. This time you're finding sine of r, cosine of r, and tangent of r. Make sure you write your answer as a fraction and as a decimal rounded to 4 decimal places.
That's why I got it.
Hayden, what did you and your partners get for the sine of r?
16 over 65, which equals to 3.5. No, I got it wrong. It's 0.7.
What is it?
0.2461.
I actually got 45 instead of 65.
0.2462. That should be a 2. Because the 5 makes the 1 round to a 2. Alright, what about cosine of r, Braxton?
What'd you say? What?
What about cosine of r?
So you gotta do 63 over 65. Oh my god. And it is 0.9692. I was rushing and then we were singing.
Alright, what about tangent of r, Colton?
16 over 0.5.
You said that's approximately what?
0.2540.
2540? Okay, awesome. Alright, you need to copy these triangles down on the independent practice. Alright, so you need to copy the triangles down as well as the measures. They're both the exact same triangle. The first one's having you do sine, cosine, and tangent of angle A, and the second one's having you do sine, cosine, and tangent of angle B. Okay, and so copy the triangles as well as the numbers. And then you will work these out on your own, and then you have a worksheet to do for homework.